Student, now we will discuss ray optics, refraction. Our topics are lateral shift and total internal reflection. Now first topic is lateral shift. So this is a glass slab placed in air of thickness T. From point A in air, the incident ray strikes the surface of glass slab at point O. From point O, this is the normal N dash. An incident ray makes an angle I with the normal and it is refracted along OB, making an angle R with the normal N dash, the angle of refraction. From point B, this is the normal dash. Now because the opposite surface of glass slabs are parallel, therefore the normal on these surface N dash and dash, they must be parallel. The refracted ray of light makes an angle R with the normal dash because the alternate angles are equal, and this ray of light emerges along BC, making an angle E with the normal dash, angle of emergence, which is equal to the angle of incident I. If glass slab is not present, the incident ray of light must move along AOD, and this is the angle theta, the angle of deviation at the refraction from point O. The angle theta is the angle of deviation by refraction at point O. And from point B, draw BL perpendicular on the initial direction of incident ray of light, which is equal to BL and is equal to D. This is called the lateral shift. The perpendicular distance between the incident ray and emergent ray when ray of light is passed through a glass slab is called lateral shift. From the figure, in right angle triangle OBL, this is triangle OBL, right angled at point L, we get BL upon OB is equal to sine theta. Height upon hypotenuse is equal to sine theta. BL is equal to D. Therefore, we get D upon OB is equal to sine I minus R, as theta plus R is equal to I, the vertical opposite angle, implies theta is equal to I minus R, or D is equal to OB into sine I minus R. Put this equation number 1. Now in right angle triangle OBN dash, in triangle OBN dash, right angled at point N dash, we get ON dash upon OB is equal to cos R. Base upon hypotenuse is equal to cos. Therefore, T upon OB is equal to cos R, because ON dash is equal to T, the thickness of the glass slab, or implies by rearranging OB is equal to T upon cos R. Putting this value in equation 1, we get D is equal to 1 upon cos R into T into sine I minus R, or D is equal to T upon cos R into sin I minus R, or D is equal to sin I minus R upon cos R into T. Put this question number 2. Now if I is equal to 0, then R is also equal to 0. That is, if ray of light strike the surface normal, the angle of incident I is equal to 0, and therefore angle of refraction R is also equal to 0. This is incident ray of light normal to the surface, and the refracted ray of light passes undeviated and again passes undeviated as a emergent ray. The incident ray, refracted ray and emergent ray, they are coincident rays. Therefore, from question 2, D is equal to sin I minus R upon cos R into T. We get D is equal to sin 0 upon cos 0 into T, implies D is equal to 0 into T upon 1 is equal to 0. That is, the lateral shift becomes 0. Now if I is equal to 90 degree, then R is equal to C, the critical angle. That is, the incident ray is grazing the surface of the glass slab, that is along AO. The angle of incident becomes 90 degree and it is refracted along OB, making an angle C with the normal NN dash, which is equal to the critical angle. At point B, this is the normal MM dash. Again, the opposite face of the glass slabs are parallel. Therefore, the normal NN dash and MM dash, they must be parallel. Therefore, the refracted ray makes an angle C with the normal MM dash because the alternate angles are equal. From point B, the ray of light emerges as parallel to the surface as BD. The angle of emergence is again become 90 degree because angle of incident I is equal to 90 degree and the opposite face of the glass slabs are parallel. The emergent ray must become is equal to angle of incident. Therefore, from question 2, D is equal to sin 90 minus C upon cos C into T. Now because sin 90 minus theta is equal to cos theta, therefore D is equal to cos C upon cos C into T. Cos C and cos C cancel each other. This implies D is equal to T, that is, the lateral shift become is equal to the thickness of the glass slab. So this is about the lateral shift when ray of light emerges from a glass slab. Now next topic is total internal reflection. So this is the surface AB separating two medium, rare medium and denser medium. Now if a ray of light enter from denser medium to rare medium, it bends away from the normal. So this is the point in denser medium O. From point O, the incident ray strikes the surface AB, and this is the normal from the point of incident, and incident ray makes angle of incident with the normal. Now some part of it refract back along the same medium, in the same medium, obeying the law of reflection, and remaining part enter into the second medium, which makes an angle or angle of refraction with the normal, and ray of light bends away from the normal because it is moving from denser to rare medium. Now if the angle of incident is increased, the angle of refraction is also increases. From point O, take another ray of light incident at the surface, making an angle of incident more than the previous angle of incident, and this is the normal at the point of incident, and makes an angle of incident with the normal, and again some part of it return back along the same path, along the same, in the same medium, and remaining part enter into the second medium, bends away from the normal. Then at a certain incident angle, the refracted ray becomes parallel to the surface separating the two medium. That is, the angle of refraction becomes 90 degree. So this is the incident ray of light incident on the surface AB. From the point of incident, this is the normal, and this is the angle of incident, such that some part return back in the same medium, obeying the law of reflection, and remaining part refracted in the second medium, such that the angle of refraction becomes 90 degree. That is, the refracted ray is parallel to the surface AB or grazing the surface AB. An angle of refraction in the rare medium is 90 degree. That incident angle in the denser medium for which angle of refraction become equal to 90 degree is called critical angle. That is, the incident angle in the denser medium for which angle of refraction becomes equal to 90 degrees is called critical angle. This is the critical angle C. Now if incident angle is further increased, then ray of light does not enter into the second medium, because the angle of refraction can never be more than 90 degree, but returns along the same medium, obeying the law of reflection. That is, this is the incident ray of light, so that this is the normal at the point of incident, and the refracted ray of light, the totally reflected in the same medium. That is, there is no refracted ray of light in the rare medium. Obeying the law of reflection, that is angle of incident is equal to angle of reflection. This phenomena of reflection of light from the rare medium, if angle of incident is greater than critical angle, is called total internal reflection. That is, the ray of light is totally reflected back in the same medium, obeying the law of reflection, and there is no refracted ray of light. Now condition for total internal reflection. Number 1, the ray of light must be entering from denser medium to rare medium. That is, the incident ray must be in denser medium. Number 2, the angle of incident must be greater than the critical angle. The angle of incident must be greater than the critical angle. So these are the conditions for the total internal reflection. The critical angle C depends upon nature of pair of media, that is, it depends on the two medium and color of light or wavelength of light and temperature. As temperature increases, C also increases, because when temperature increases, the refractive index of the medium decreases and critical angle will increase. This is about the total internal reflection when ray of light entering from denser medium to rare medium and incident angle is more than critical angle, then it is totally reflected back in the same medium and there is no refracted ray of light. That is why it is called total internal reflection. Thank you very much.